First step here is going to be knocking the main pin out. Oopsies. We'll find out. Nothing to it. Before I lose that, maybe we ought to do a quick little check here. 23.5. 23. Man, both of those add up to half, so should be tight. All right, let's see what we got. I think we need a little more side shift to the right. I'm gonna put the old pin back in from the right side. That way, once I cut that tang off, drill a hole in the new pin, we can drive it in this way and push that pin out by the time it gets there. I think something we're gonna have to change here. The grease fitting comes out here. Grease fitting, grease, which is great. There's a bushing there, you can see in the thumb. But this pin's on, so this is always going to turn with the thumb, which would put your wear point on the quick coupler over here, which is no good because that's not a meant to turn greasable surface. The old pin, you can see it had a hole here where the pin went through the quick coupler to it, or the bucket if you didn't have a quick coupler. I think what we need to do is drill that hole in this pin. After that precision alignment. This spacer ring fits in there pretty nice. I mean, a little bit of slop, but I think good enough for who it's for. Firing up the beast. She's old, but she still gets the job done. It's a milling job. Call that good. All we're going to do is we're going to do a drill cycle, VS4, and we have our 0.78 drill somewhere in here. Tool 1. We could change this down at the machine easily. So if that's a 5/8 drill, we have it going 100 surface feet a minute. If we're able to run a carbide insert, we can probably run this about 300. And a little harder. 3.5 mil per rev. Or flood coolant. Then we just pick this hole. And then on our desk, I'm going to drill tip through the bottom. We're going to do some chip breaking here. Alright, so this is the G code we just wrote with HSM Works inside of SolidWorks. Each one of these is basically an XYZ coordinate telling the machine where to go. This could be a CAN cycle, but this is how the machine posts it. It's going to work just fine for what we're doing. Basically, the feed rate is inches per minute that the machine's moving, and each one of these lines just tells it what step to take. So because we're pecking, there's a bunch that's going down and back up, down and back up, down and back up. And after so far, it'll pull up a bunch for a full retract. But
you get the idea. It's just telling the machine where to go.
So I'm gonna probe the part so that we know where it is. That probed our X. I want to probe this roughly where we're going to be in case these two vices aren't lined up. Alright, we're doing a web. Work offset 1. Width we're going to call it 4. -2. Put that in MDI. And try it again. Make sure your probe's not going to hit. And that'll find the center for us. You can see it walk back to the center. Now the only thing left to do is probe the Z surface. Save that one in memory. Come down. Touch off in Z. All there is to that, we're all set up. So our origin is over there, because we touched off our X there on that flange. Our Y is in the middle of the whole thing, obviously, but just in case we're out of straightness, I wanted to do it down here where we're going to be drilling. And we touched our Z off right there after we found center, so we know we're on the top of the circle. And we're ready to go. I think I'm going to change the program a little bit. I want to start with one of the insert drills, and since now we're just using a high-speed steel drill, I want to give it basically a pilot surface since we're on this round rod, and then I'm going to slow down the feeds and speeds with the high-speed steel drill bit. I have the program on this thumb drive. I'm going to select it to copy it to memory on the old girl. Alright, so basically what we're going to do is we're going to take this indexable drill, it's like 0.8-ish diameter. We're going to go down about 100,000, or yeah, about 100 thousandths deep, basically to give a starter, and then we're going to switch to that 3/4 inch high-speed steel drill bit and just take it nice and easy. It's only run about 100 feet of surface speed, and I think 9 thousandths per revolution is what I went with from a quick little Google. And I'm going to be running flood coolant, so we're going to have to shut the doors. Looks like we are in relatively the right spot. Just slowing things down here. All right. As you can see, nice little starter mark there. These are an insert carbide, basically a solid chunk of carbide that twists onto the drill body, and these are very rigid, so they're good for doing things like that. And now that we have that part there, when we change tools to the next drill bit here, we will be much closer to where we want to be. So that thing just downshifted with its little hesitation there. Stopped it. Coolant down there a little bit better. Retract. You can see how that pecking is helping to break the chips. And then we pull out all the way to get more coolant down in the hole and help chips. And we're through. That's all there is to it. So because I only drilled a 3/4 hole for a 3/4 bolt, because that's what we had, I just went and grabbed a 3/4 bolt out of the bin. It does work. Not a lot of wiggle room, so hopefully the holes are pretty accurate in the quick coupler. Otherwise we'll be egging them out a little bit, but hopefully we can get this thing pounded in and line it up with the bar good enough to get the bolt through in the machine. So the next step here is to cut this flange. So the next step here is to cut this flange off the end. We don't need this. They had this thing hooked to the thumb for some reason. We drilled that hole because I wanted to pivot with the bucket slash quick coupler. So what I'm going to do is take the torch and try to burn this inside weld out of here. And I'm hoping that I can basically get cutting, flip on the weld positioner, and just basically keep cutting down. So I've never tried to torch on a positioner. No idea how this is going to go. We're going to find out. Don't be ugly. Clean it up a bit. Good enough. So the reason I'm doing this way and not in a lathe is because I do not have a lathe that this will fit in the spindle. The only way I'll be able to do this is set it up in a steady rest, and I have a steady rest in the lodge at home. Not to say I couldn't do that, but I really didn't want to get into it all for what we're doing with it. I think this will be all right. We'll slap some paint on it, cover it up good enough, and roll with it. So what I want to do here is at least inspect these bushings in here, because I have these new ones, because this machine did have a little slop in the bucket out here. So what I'm hoping is these will take care of that. I want to check everything, make sure it looks right. I'll try to hit on this with the pipe and the hammer a little bit, but I'm thinking the easiest way to get them out is most likely going to be to take the stick welder and just weld a couple beads around there. That'll cool and shrink, get them out. It'll be the surefire way. But we'll see if we can get them to move first. Let's see if she'll move. Well, they're not falling out, but the good news on that is the stick must not be all worn out either. So look at the positives here. All right, hopefully we can get a good ground and connection, and let's see what we got. Nope. Oh, there we go. I don't think that these are steel bushings like the ones I got, because I don't think it's welding. It's just kind of gouging, if you will. I don't think it's hurting the cause though. I'm on fire. Huh. I'm regretting hitting that with the welder already. All right, if there would be something to try to film, it would be what I'm gonna try next, which is to air arc with a stick welder. I don't have an air arc set up, but I'm saying, why can't we use a blowgun and the stick welder, which isn't seeming to want to weld anyway? But Hey, what's the worst that happens? We destroy something? Well, I think we very lightly gouged it. I'm wondering if I crank the amperage up. Round two. Guess maybe if I start at the front, I could see it better. If you just had a carbon gouging rod, it'd probably be all you need for this. Almost seems like the grease fire might warm up the whole stick enough to make that bearing coming out a little easier. I think that a lot of that grease has to get cleaned up. Things are getting a little wild, and I need to go to bed. But I figure while this is hot, we can get that grease out and put the fire out, hopefully. We're gonna see why they tell you not to fight grease fires with water, though. Hopefully I don't soak a GoPro. Oh, so sweet. All right, so you can see the pure and utter destruction that we caused this poor little bushing. We'll figure out a way to get him out. We're committed now. So thanks to Amazon, I've acquired a gouging setup for 50 bucks. I got a couple of 3/16 carbon rods, and we're gonna see if we can figure this out. I got an old lawnmower blade I wanna try this out on first because I've never done it before. But basically it's like a normal stick stinger, except for you hook an air hose. There's a barb on this thing. I just rigged this up, clamped the normal stinger to it. But air, you could control the air with this little slide here. Air blasts out of these holes. So as you're basically making a puddle, say with the carbon rod, it's just blasting the molten metal out of there with just regular shop air. So let's see what we can destroy. Here we go. Hopefully I don't destroy the stick. Work our way through this terrible hole I did the other night. So a lot of that ugliness is from our stick welding endeavor the other night. But I'm most of the way through. That back needs a little bit more. Let me go grab another electrode. It moved. Yeah, you can see, okay, so we'll be able to drive it out now. So you can see it actually cracked its way free the whole way. Got a little gap there. It started to curl up. I guess I'll go grab the digging bar and the sledge and try to get in from the back. There's only that wee little lip to catch, see if I can drive it this way. Sweet, we didn't even destroy it. Just a little wee bit of stuff there. That's like extra still on it. A couple little spots just need to buff out. That went well. I'm happy with that. On to side 2. It seems like it really likes to push away from you. So I'm going to try to keep that rolling. Start right through that seal and keep on trucking. There it is. Take a look at that. Just no damage. No damage to that at all. That is a very convenient process. I'm sure I'll be coming up with more uses for that. But I'm going to clean up these bores. A little flap wheel action there. I'm going to clean up this edge of hair. And be ready to put the new bushings in. Stay tuned. Grease holes staying lined up. Sounded solid. Just Other side fired right in there. We need to help a little chamfer on that. man, that thing is tight. Yes, the right way to do this would be to use a hollow inner pack, which we have, but we don't have a long enough piece of all thread. So we're gonna beat the wang out of it like a true butcher and just put it in there. Because we're committed now. I don't think it's gonna fall out. I don't think these cheapo depot bushings are what do I want to say, oil impregnated like the original ones. So if they wear out in my lifetime, as much use as this machine gets, I doubt it. I think you will be able to just weld a bead around the inside though. This is the good news. Alrighty guys, I'm gonna try to test fit the pin before we actually put this together. There seems to be a fair bit of slop in this pin, so that's not bad once it's in there. Okay. All right, well, everything clears, goes through. Gonna start the machine and lower the stick down in there and try to put it together, I guess. As I thought may be the case, those lugs are hitting the stick first for this stuff, because I thought I could take the torch and trim that off, but apparently that's not necessary, as it doesn't help you any. That's still pretty far out of the way. I think what I'm going to do is tack it up, and then what I can do is put the bucket back on and kind of test it out through its range of motion before I go hog wild on the welding. Oh yeah, something dead, something good. Surprised you weren't rolling in it. Good boy, Yogs. Alright, I threw that ratchet strap around the cylinder. There's a chain hooked to the thumb. So what I'm gonna do first here, I'm running 60-13 1/8 rod because that's what we got, the only thing we had. I'm gonna go ahead and put 4 decent tacks on this, and then what I want to do is put the bucket on, just kind of check everything out, make sure this thing will go through its range of motion, all that jazz. Well, that's some good enough welds. Nothing to write home about, but I don't think it's going to fall off there. And that completes the mechanical portion of this installation. Next up, figuring out our hydraulic solution so we can actually move this thing, but at least it's on there. And this thing is now usable again because the thumb's chained up. A little, oh yeah.